Hello friend, we have disconnected last times, then we are going to continue these questions on the determinant added and added vector. In the last video we have discussions about we have calculating the mass stiffness matrix, mass matrix, stiffness matrix, and how do we compute it omega. We have again repeat this. Now here we have the three-story building. On the three-story building, we are going to analyze the three-story building, and this is the related to the subject structural dynamics on the multi-degree of freedom problem. And there is the given mass and stiffness on the all the grounds. And here we have calculated the mass in this form. Always we have put the mass matrix in this form. So we have given all the data in the input, and the K matrix will have to be calculated where the load apply like this, where the load apply, at what position the load apply, and what was the effect at that position, so another position. When the load Q11 means the load apply at one positions, and what was the effect at one position. One position equal to position 1. What was the effect of unit load at one positions? That we have calculated like this. In the previous that we have to go previous video, we have to see that, and here we have calculated this value K1, and now using the characteristic equations we have calculating the omega. How? There is the omega has the three value, because the three-story building there will be the must be known the three or known W1 W2 W. How we calculated? There we have calculated the F matrix, that is in the inner part of the characteristic equation, that is K matrix minus omega square minus M, where omega square this we have not put the anything, so omega is equal to this value is something 0, and this value is equal to dash omega square dash 0, and we have solved this matrix F matrix, and finding the determinant of this matrix, and using the solve function, we have to go the data, and so using the solve function we have to put the objective value, that is F matrix, and the value is equal to 0, and the changing value is omega what we have to be calculated, and there is no you have not put anything like this one, and you have to press solve and okay. You have got the first one value, this one, and again you have solved, and again we have solved 8. This value must be greater. If you get the 7, that must be greater, and solve, and again you have got the 18.3, and again you have to put the 20, that is greater than 18, and you have get the greater than 18 value. You have got these three value, and after that using this equation we have calculated the mode matrix, that is K times omega square into M, that is K. This matrix is equal to K minus omega square M, this matrix, okay, and into phi matrix. Here we have calculated solving the equation. Here we learn the phi 1 is equal to 1 1, and solving these equations, solving we have get the phi 1 1 mod 1 for model 1 omega for first model omega 1 for model matrix find, and again for the similar we have calculated the phi 1, and solving these equations we have get phi 1 1 2 phi 1 2 phi 1 3, and this is also the for the second third matrix, and there is the model matrix of the combinations of all these three mode. We have got the model matrix, and after that we have calculating the mod using this equation. We have got this, and this. We have here we have to put the in the series a small to greater, we have put this value, and here we have calculated this graph related to this value. We have to go in the previous video, we have given same that things, and we have calculated three different mode, okay. Then there was disconnected, and what we have become generalized mass. Generalized mass means the formula of that mass, mi is equal to phi I times t m phi I, that is phi I. We have the phi 1 matrix, that is phi 1 1 phi 2 2 for first mode. We have got already calculated this value into here using these equations. Using these equations we have calculated phi 1, and the transpose of this matrix are this. This is our transpose of this matrix, and M we have the already given in the questions, and we have calculated M1, that is Mi, that is means that phi transpose this into this matrix multiplication first, then we have to get this matrix and multiply this matrix with m times this times this. Here we are calculating this matrix into this matrix is this, and this matrix into this matrix is this. That is, there you can see this into this plus this into this plus this into this is equal to this value, and here this into this plus this into this plus this into this is equal to this value. Get okay. Here we have got, and this matrix will be multiplied with the phi matrix, and we have got this matrix, that is this into this plus this into this plus this is equal to m1 generalized mass m1. Generalized mass here. Similarly, we have put the phi 2. You have to change only phi, and all other terms are additive, and you have calculated like this. This into this is equal to this into this you have calculated, and you have got this matrix, and that this matrix is the. Similarly, you have calculated the for the mode. This is mode first, second mode. This is second mode, and we have calculated for Eigen and the third mode. You calculated the third mode. Similarly, process you have calculated, okay, and after that you have calculated the generalized stiffness. Generalized stiffness matrix. Okay. Generalized stiffness matrix. Here nothing. Instead of m, you have put the k matrix, okay, and then you have to calculate phi 1 k, and here this is for first mode is all, okay, and this is for second mode, and this is for third mode. First mode, how we calculate. Similarly, right math, you have to get the phi 1 matrix. It is already calculated here. Here you have already calculated this value, and again k matrix and the given matrix we are already calculated in the first video, and this value came where we have come from the q1, that is k time, that is phi 1 transposed into k, that is this matrix are used here. Alright, this value and this value are the same. Here what we have to do, D98, that is 98, okay, instead of 98 we have put 119 119 okay. We have got this value, and after that this value, this into this plus this into this we have got, and similarly we have calculated this one also. So the 98 we have to put 119. See, Control V, okay. They are not same because these stiffness are the same. So okay, Okay, you have calculated this, and again we have calculated this and this into this plus this into this multiplication, the simple matrix multiplication. Here we have got k1, k2, k3, and at last we have got the serial number, modal, first mode, second mode, omega 1, omega 2, 3 mode, and the three different mode, 3 omega, generalized mass, 3 different masses, and the generalized distribution, 3 different analysis mass. And finally we have got the orthogonal equations. Orthogonal equations, that means phi I transpose into m into phi j is equal to 0, or we have also calculated this in this way, phi I transpose into q into phi j is equal to 0. Here you have calculated the similarly like this process in the mode matrix or the stiffness matrix. We have calculated this, and similarly you have calculated, and we have got the that is mass q1 is equal to something, this value must be 0 here, q1. Here we have calculated g1, but we have not calculated this, so this product is equal to 0 here, 0 matrix, that is 0, so that we have verified the orthogonality properties. If there is any query of this problem related to this problem, then you have to text me. I will definitely reply you and try to solve it. In this channels we are going to do uploading the most of the problem related to the civil engineering base, and here we have also uploaded all the details from the starting to ending of final year project of BCE bachelor, where we have seismically resistance building, and let's the seismically resistant building from the preliminary design to the final we have calculated. Thanks for watching these videos. Bye. We'll meet soon.